when you have something like square root of A times square root of B, this is the same thing as square root of A times B. For instance, let's make use of numbers. Let's say we are given something like square root of 2 times square root of 3. So this is something as square root of 2 times 3, which will give us square root of 6. Alright, so when you break square root of 6 down, you get a result. Let's look at another example. We have something like square root of A times square root of A. This is something as square root of A times A, which will give us square root of A square. Okay, square root of A square. Now, this square, we cancel this square root. So our final result will be what? A. This is basically what it's saying. So it's advisable you, before you cancel, enclose it with bracket like this. So the square, we cancel the square root. Okay, now that's the first rule of sorts. When you have two values multiplying each other, so you break them, the two values together in a single bracket. Okay, now let's look at the second rule, which is the division rule. When you have something like square root of A over square root of B, so this is something as square root of A over B. Okay, now let's make use of numbers. Or if you have something like square root of 8 over square root of 2, now this is the same thing as square root of 8 over 2. So 2 will cancel this one. Now we'll be left with square root of 4, and square root of 4 will give us what? 2. Some say it's plus or negative 2, but we make use of the plus sign. That's why we say that the square root of this will give us what? 2. So that's just for the second rule. Now let's look at the third rule. Now when you have something like this, square root of A plus square root of B. Now this is not the same thing as square root of A plus B. This is erroneous, very, very bad, not correct. Right? When you are having plus sign, don't do it like this. This is the same thing as square root of A plus square root of B. Just do nothing about it. Okay, now let's wipe this and look at the fourth rule. Okay, now for the fourth rule, this one is a bit tricky, but I'm going to simplify it or break it down. Now when you have something like this, we have a bracket A plus square root of B square. Okay, now this thing is the same thing as A square plus 2A square root of B plus B. Now let me show you how we got this. Just like we did in factorization of algebraic expression that involves difference of 2 square. Okay, now if we break this down, A plus square root of B, A plus square root of B. So this is what it means. When you simplify this guy, we're going to have A returns A plus square root of B, alright, plus square root of B times A plus square root of B. So when you simplify, we're going to have A square plus A square root of B plus A square root of B plus, now we have square root of B times square root of B. This is something as square root of B times B. The first rule we looked at. So when you break this down, this is something as square root of B square. This square will cancel the square root, so this square cancels the square root here. Our final result will now be A square, A square root of B plus A square root of B will give us plus 2A square root of B. We're now left with, since we have simplified, this is B, since we have simplified square root of B times square root of B, and we got it to be B, so plus B. So that's how we got this guy. So don't be confused with it. Now let's look at the fifth rule. Let's wipe this. When we have something like this in bracket A plus square root of B, okay, and bracket A minus square root of B, and we asked to simplify this sort. This guy, our result, our final answer would be A square. This is something like A square minus B. Let me show you how you will get to A square minus B. The same technique. Now, just like when you are multiplying algebraic expressions that has double brackets. So this is going to be a in bracket a minus square root of b, all right, plus square root of b in bracket a minus square root of b. So when you simplify this, I'm going to have a square minus a square root of b plus a square root of b. Now we now have b squared times minus b squared. We're going to have minus square root of b times b. Square root of b times b to give us square root of b square. So this, you enclose it like this. This square cancel the square root. So our final result will now be a square minus a square root of b plus minus plus a square root of b will give us 0. Alright. Just like saying minus 1 plus 1 will give you 0. Okay. So we will left with a square minus b. Alright, so that's how we got this. So it's as simple as that. Now let's write this now. Look at the last rule for Surds. Okay, now the last rule, PAC, will involve rationalization of Surds. If you have something like a over square root of b, this is something as a over square root of b times square root of b over square root of b. So that's what it will imply. Okay, if you have something like, let me just say, just take this rule involving rationalization. I want to explain something. This way I give you something like a over a minus, or let me not use a this time around. Let me use c minus b, or let me use a positive sign here, rather, or either positive or negative sign. The same principle. Now this, if you want to rationalize this kind of sort, this will be a over c plus b times, this time around, this sign will change to c minus b over c minus b. Alright, so when you are dealing with surds, you want to rationalize the surd and the denominator, we have either a positive sign or a negative sign in between them, just like here. All you simply have to do when you're rationalizing, when you get to here, you invert or change the sign of the original sign the question is having at the denominator. Alright, so that's basically what I want to explain.